Hello intellectuals, and Mr. Davis.
Wow!
Today we will be talking about titrating an acid and a base and finding its equivalence point and its half equivalence point, along with the importance of finding its half equivalence point. So firstly, let's draw a titration curve. Of course, with different combinations of acids and different bases, there will be slight variations to the shape and the slant of the curve, but for simplicity and life, this will do for now. Notice how, as we increase the volume of the base, or more specifically the volume of the titrant, there comes the region where the curve somewhat slants vertically upwards.
Not really vertically upwards, but let's just say that it is.
Well, at the middle of this ascent is what we call the equivalence point. This point is where the titrant has completely neutralized the analate, leaving only salt and water. So let's say we choose ethanoic acid to be our acid. It's a relatively weak acid, so it only partially ionizes. And let's say we choose sodium hydroxide as our base. It's a strong base, so it really ionizes in water into this. Put them together, ethanoic acid and sodium hydroxide. At the equivalence point, we would get this. However, the interesting bit is not the neutralization reaction, but the half neutralization reaction. So theoretically speaking, we can kind of assume that at the half neutralization point, only half of ethanoic acid has reacted with sodium hydroxide. That means that the concentration of ethanoic ions are the same as the concentration of ethanoic acid. So this is actually really significant because we can plug it into this equation. And one thing we notice that because the concentration are the same, the fraction of, salt over acid becomes 1. And with maths, we know that log anything of 1 is 0. So that kind of spice up the equation, making the pH equal to the pKa. And this simplifies a lot of things. And the significance truly just lies in the fact that it's simplified into pH equals to pKa, because that way we can choose the pH of our buffer solution by choosing an acid of the base with the closest pKa to the pH. And, we probably have a table of values of, different acid dissociation constants. And it just makes it a lot easier to pick a buffer. Same idea of finding the half neutralization point and the pKa of buffers. This whole thing works the same way with diprotic acids or triprotic acids. I just specifically chose a monoprotic acid because it just simplifies the topic best. But however, the same ideology of half equivalence point and whatever really applies to any titration curve. Just have to put some brain cells into it,
Wow!
That's it for now, until Mr. Davis decides that he wants me to do another video.